You've probably heard of AI solving chess and Go, but is it possible for it to learn risk like a human gambler? If you give an AI some cash and a deck of cards, will it make a fortune or will it go broke? Today, we're teaching our AI player Max to play Blackjack. Check out my last video to see how Max got his name. As per usual, we first need to code up the game, so let's do that now. We'll first add all the necessary elements to the HTML canvas. This will be a browser version of Blackjack. Okay, that looks terrible. We'd better add some styling next. Okay, that's looking much better than before. When we add the cards, they'll be shown under the dealer and player labels. But our game still doesn't work. So let's start coding the game mechanics. For those of you who have never played Blackjack, I'll quickly break it down. Each player competes against the dealer. In our case, it's just us playing. The goal is simple. Get as close to 21 without going over. Number cards are worth their face value. Face cards are worth 10, and aces count as 1 or 11. Both you and the dealer start with 2 cards. You can hit to take another card, or stand to keep your total. If your hand goes over 21, you bust and lose automatically. After the player stands, the dealer must draw until reaching 17 or higher. Whoever's total is closer to 21 wins, unless you bust first or tie, which is called a push. We'll code this gameplay logic now, and then have the outcome message and cards rendered to the UI. Okay, let's try dealing the cards and playing a game. We should hit since we only have 9, and shit, we still lost. At least we know the game is working though. Let's try playing a few more times. Honestly, 4 wins and 4 losses is pretty solid. We essentially just broke even. Now for the fun part. It's time to teach Max how to play. We can start by adding some buttons to start training Max, our AI player, and allow him to start playing. The View AI Values button will allow us to see the results of training. Stay tuned to see this later. We'll add a quick status element that will enable us to see the progress of our AI training session. Now, we can start with the main AI functionality. To teach Max Blackjack, we'll use Monte Carlo reinforcement learning. This means that Max will teach himself by playing thousands of simulated games. Each round, he makes random choices to hit or stand, records the outcome, and slowly builds a Q table, a memory of which decisions work best in each situation. Q in Q table comes from quality of action because it measures the quality of choosing a specific action in a given situation. A policy is the AI's current strategy. At first, a policy is random, but as Max learns, the policy evolves to favor choices that lead to higher rewards. We call a single game the AI plays an episode. It's a self-contained round where the AI tries actions, gets a result, and learns from that outcome. A return is the total reward the AI receives from a single episode, based on how good or bad the entire game turned out. We'll have a function to simulate a single episode, and then we'll use it thousands of times to train Max and construct our Q table. We'll now start adding this functionality to our UI buttons, so we can control when we train Max and have him play autonomously. We'll also add an overlay element so that when we want to view the QTable results of our AI training session, we can render them to the screen. Once the AI is done training, we'll enable all the buttons so that we can have it play either one round or multiple rounds continuously, and so that we can view the learned Q values. So now, if we train Max, we can view the full QTable by clicking the View AI Values button. This is essentially Max's memories. For example, given a state like 17-7 true, which represents Max's current hand as 17, the dealer's hand as 7, and the fact that Max has a usable ace as true, we get the expected return if Max chooses hit or stand from that state. Max makes his choice based on whichever action gives a higher return. Once we train Max, we can have him play either a single round or multiple rounds automatically. Starting with single rounds, let's see how he does. Three wins, one loss. Not bad, Max, but this could have been a fluke. We need to see what the win ratio actually converges to later. Each time we train Max, we get a new set of Q values that dictate that version of Max's decision-making process. Now let's have him play continuously and see what his win ratio converges to. Seven wins, 12 losses, and 4 ties. That's not great. And if this was real, Max would have lost $250. I'm going to tweak our training simulation slightly. I'm going to have Max train on a larger number of games and see if that helps. Currently, we're training Max on 30,000 episodes. Let's try increasing that to 100,000. Also, to get a better idea of what Max's win ratio actually converges to, I'm gonna have Max play out a larger number of games, maybe around 100. So I'll decrease the time between rounds from 800 to 200 milliseconds. Let's see how he does now. Still not a great win ratio. Let's try again, training on 300,000 episodes and decreasing the time between rounds to only 50 milliseconds. I think we're sensing a common pattern here, but we'll do it one last time with 500,000 training episodes, just to be sure. Come on, Max. Our last set of Q values is set. So let's see how Max plays one last time with the most training episodes so far. Maybe he'll make an improvement, but I'm not super confident. So I guess the main takeaway is that AI sucks at gambling, and gambling is terrible, so you should never do it. In all seriousness, Blackjack is designed to favor the house in the long run. Since the player always has to make the first move, they will always have the possibility of busting first, regardless of whether the dealer busts afterwards. Even if AI learns the optimal policy, it'll only approach break-even at best, which is roughly what we saw with Max. So if you ever want to play Blackjack at a casino, make sure you're also okay with losing money. Subscribe if you made it this far, and comment what you want me to teach AI to do next. See you in the next one.